Yes. What is this? What is this word conditional probability meaning here? Let's see. So let x and y be two events associated with a random experiment. Then the probability of occurrence of x under the condition that y has already occurred. I'll explain with an example later. For now, try to understand. If x and y are two events associated with any random experiment, then what they're telling here is probability of an event of occurrence of x provided y has already occurred. So do you understand? For example, I want to I want if there are A, B, C, D, some random people are playing a game. Probability that A will win given B has already lost. That's what conditional is now. Now I am giving a condition for the event. A has to win this game provided B has not won the game. Okay, is it making sense? Maybe some other example. Assuming A, B, C, D, E are five friends. They are going to attend an event in such a way that probability that A will attend the event given B has already attended the event. So this is making sense, right? So that is, I am going to, if it is just directly asking PA has attended the event, we might have a direct probability. But now we are giving a condition. A has to attend the event after B has attended the event, or B has on a condition that B has already attended the event. That is called conditional probability. And it is symbolically represented like this. If I say P of x bar y, meaning is probability that x has occurred given that y has occurred. Okay. And how do you write this is P of x bar y, and the formula for this is P of x intersection y divided by P of y. This is how we calculate. Okay, let me give an example. Uh, say, let's take a sample space of having at least two heads in a three toss. In a three coins toss, I need to have at least two heads. Okay, so what are the at least two heads means we'll have two heads, one tail. Okay, and then tail, head, and then head, tail, head, and then all are head. Okay, this is our having at least two heads. Now further in that a condition is the first toss has to be toss has to result in tail. Now tell me how do you solve this? First toss has to be tail. So we have to further come to this, right? So first I need to have the condition is like this is say B and this is A. So my condition is now P of B by A, conditional probability. So the first toss has to be tail out of the probability that we are getting at least two heads. So how do you write this is P of A intersection B divided by P of A. So what is P of A? P of A intersection B is out of these four, what we have, we need to have first one tail. So that is 1 divided by 4 divided by 1 divided by what we have is, yeah, that is 1 by 4. The numerator is, we'll have this much, right? What is the value we have is, this will be giving you how many ways denominator is how much? 2 cube 8, right? The numerator what you have 1, 2, 3, 4, 4 by 8, which is 1 by 2. So this will be 1 by 4, this will be 1 by 2. So our answer is 1 by 2 at the end because the probability is always less than this. This can be an example to show conditional probability. So let us see more examples like this to understand better. Okay, so let's take some solved example. So we can have some solved examples in the previous set, its previous slide itself. Let's see the one which I skipped in the introduction slides. Yes. This is A. A is nothing but P in this case. Let's take it as given that X and Y are even such that P of X is equal to how much? Px is equal to how much? Yes. That is probability of occurrence of X is equal to 0.8. P of Y is equal to 0.4 and P of X bar Y and P of Y bar X. That is P of X has occurred. I mean P of occurrence of X where Y has already occurred. P of occurrence of Y where X has already occurred. So as we know P of X is equal to 0.8. P of Y is equal to 0.4. So we need to understand what is P of X intersection Y is also given 0.2. Okay. So in that case, can we not find P of this one? Yes, we can easily find P of X bar Y is P of X intersection Y by P of Y. So what is X intersection Y? 0.2. And this is 0.4, which is 1 by 2. Similarly, P of Y intersection X is 0.2 divided by 0.8, which is 1 by 4. It's a direct question. Okay, so we don't have to think anything. We just have to substitute in the formula to get the answer for this question. Let's see the next question. What we have. If P of X is equal to 0.8 and P of Y is equal to 0.5. Find P of, also they are given P of Y by X is equal to 0.4. Then what is P of X intersection Y? So how to connect them? They are given this, right? So using this formula, P of Y intersection X is equal to P of X intersection Y divided by P of X. So we substitute the values. This is 0.4. This is what we have to find out. Numerator, denominator is 0.8. So what is 0.8 into 0.4, which is 0.32. So the answer for the first question is 0.32. Am I right? Yes. Next question, second sub question. P of X bar Y, that is probability of occurrence of X where Y has already occurred, which is given by P of X intersection Y divided by P of Y. For that, we already have P of X bar Y, which is 0.32 divided by P of X is how much? 0.8. Which is written as 0.8 into 0.4 divided by 0.8. 0.88 cancels, we get the answer 0.4, which is option. We don't have an option here, so the answer is 0.4. Last one, what is P of X union by Y? So for the X union Y, we have the formula. What is the formula? P of X union Y is equal to P of X plus P of Y minus P of X intersection Y. For all this, we have to find P of X intersection Y, right? So this is our left-hand side. We have to find out P of X is 0.8, P of Y is 0.5 minus P of X intersection Y is 0.32. So what we have is 1.3 minus 0.32. So if you remove 1.3 minus 0.3, we'll have 1 minus 0.02. It will give you what? 0.98. That's your answer. So if I'm not wrong, answer should be matching. Let's see what is the answer we have. Yeah, 0.98. Can you see that? Yes. There's another example here. Quickly, we'll solve them also. P of x union y, that's either x or y, we have to find out if 2 times p of x is equal to p of y, which is equal to 5 by 13. And p of x bar y is equal to 2 by 5. Okay, this is what they are given. First, we will try to first find out p of x and p of y clearly. Okay, so if p of y is equal to 5 by 13, p of x will be half of p of y, which is 5 by 26. Okay, now if you want to find p of x union y, we need to have p of x intersection y, right? So p of x intersection y is missing. To find that, what we need, I will write here, p of uh, x. What is the information they are given? This is equal to 2 by 5. So 2 by 5 is equal to p of x intersection y divided by p of y. So p of x intersection y is equal to 2 by 5 into p of y. What is p of y? We have 5 by 13. Very good. So that means it is going to be 5 cancels 2 by 13. That is p of x intersection y. Now if we have everything now, right? So p of x union y is equal to p of x plus p of y minus p of x intersection y. What is p of x? P of x is 5 by 26. P of y is 5 by 13 minus 2 by 13, which is 5 by 26 plus 3 by 13. LCM is 26. So it is 5 plus 6, which is simply 11 by 26. And that's the answer we have. So if we have done the calculation correctly, it has to give you 11 by 26. So these examples are clear, I guess. Yes. Yes. So as this topic can be a big headache if you don't understand the concepts, I am focusing more on the examples before getting into the actual questions. Okay. And we want to make sure that our concepts are very clear so that there won't be any confusions while understanding these questions in the exam. Right? Yes. Let's solve some more solved examples. Let's check under conditional probability. Can you please read this question quickly? Anusha and Ankita took turns rolling a die with 3 green and 3 white faces. A die has 3 green and 3 white faces, right? Just remember, let me erase this. You know how the die looks like, right? Die has how many faces? Yes, a die has how many faces? 6 faces. In that 6 faces, it is told that 3 faces are green and 3 faces are white. Right? Yes. So 3 green faces and 3 white faces. Okay. So let us assume the right is white. Okay, how it is painted, let's not worry about that much until they mention that specifically. So it's three green faces and three white faces. Until one of them turned green and lost the match. Okay. Anusha and Ankita took turns rolling a die with three green and three white faces until one of them turned green and lost the game. That means they start turning it until it turns green. So if they doesn't turn green, they keep playing it. Okay. Once it turns green, they will the one whoever throw the die will be losing the game. If Anusha initiates the game, what is the likelihood that Ankita would lose? This is a question. Can you understand this question? And can you relate it in a real life scenario? Anusha and Ankita took turns rolling a die that has three green faces and three white faces. Simple. Okay, so this part is clear? Yes. Now, how the game goes is if they start turning and throwing the dice, somebody has to lose. When they will lose? When the die turned green. Okay, so what is the chance that Ankita would lose when Anushka started? Okay, so how to solve this? The probability that die showing is going to be uh, what white face or green face is what 1 by 2. Okay, equal chances. Anusha loses the game if she gets a green, uh, right? First, third, fifth, or seventh because she is the one who is going to start the game. So if she is starting the game, if the first row throw only, if she is getting green, she is lost. Or it will go to third, she will come to third again. Then she will come to throw fifth time and then seventh time. What are these numbers? Odd number of times, right? So that means the probability that Anusha loses to Ankita will be given by 1 by 2, or if it is 3 times 1 by 2 cube, 1 by 2 power 5, fifth time 1 by 2 power 7, it goes like 1 by 2 power 2n plus 1 because it's odd number, right? So that is the chances that she can lose the game. So the answer to this question is going to be now an infinite series. What is that? The chance will be 1 by 2 plus 1 by 2 cube, 1 by 2 power, what is it? 5 till 1 by 2 power 2n plus 1. So we can take 1 by 2 common, becomes 1 plus 1 by, what is it? 2 square plus 1 by 2 power 4 till infinity. So it's a geometric progression, right? Where a is 1 and r is 1 by 2. So what is sum of the infinite series formula? A by 1 minus r. So this sum will become 1 by 1 minus 1 by 2, which will become 2. So this entire problem will become, what will happen to this entire problem? Can you check? So this sum, this is now 1 by 4, okay, not 1 by 2, r is 1 by 4. It's going to be 1 minus 1 by 4. This will become 4 by 3. So our answer will become 1 by 2 into 4 by 3. So 2 ones are 2 twos. So the chance of Anusha losing the game is 2 by 3. Okay, if Anusha loses the game, what is our question? So let's read the question again. Our question is mainly talking about who has to lose the game. Ankita should lose. If Anusha can lose the game at the chance of 2 by 3, 2 by 3, Ankita will lose with 1 minus 2 by 3 because there are only two people playing the game. That is 1 by 3. Is it that difficult to understand? So if it is so difficult, you have to practice more and more such questions. Okay? Yes. With this example, I'm going to wind up this class. So let us summarize what and all we learned today. We did not enter into the actual crux of the topic yet. We have just understood the basics. Why I emphasize on this basic is because we would have learned in the 11th standard and forgotten. Even in the 11th standard, most of you would have skipped this chapter because you were struggling to understand permutation combination. But now again, we cannot take the chance of skipping this topic. Instead, we have to learn this topic so that we can score better. Okay. So what I am going to tell you right now is to summary of the class so that we can continue from here on tomorrow's class. So let's see the summary of today's class quickly. So what and all we covered today? What is the order? We have just learned the basics, right? So yes. The basics of probability. Let's go back. Yes. So let me list out the things we learned. First, we understood what is an experiment. We recalled the definition of experiment and types of experiment. In that, we understood what is random experiment. Why is it called random experiment, right? Then we came to know what is an event, what is an outcome. What is an outcome? Result of a random experiment is an outcome. Conducting an experiment is an event. Okay, or expecting a particular result is an event. Okay, so then we defined the probability of an event, which is ratio of the number of favorable outcomes divided by total number of outcomes, right? And what is the range of the probability? Probability always lies between 0 and 1. So based on that, we understood the probability of an event is 1 means it is sure event or certain event, and probability of an event is 0 means something which is never going to happen in reality, that is impossible event, right? Yes. What else we understood? Types of event: independent event and then dependent event, right? So then definition of mutually exclusive event. What are mutually exclusive event? Two or more events are said to be mutually exclusive if the occurrence of one event completely stops the occurrence of the other. Okay, and collectively exhaustive. Two events are said to be collectively exhaustive if two or more events, if they completely exhaust the sample space, nothing else is left in the sample space. Okay, and if two events are collectively exhaustive and mutually exclusive, we know their sum of their probability will be equal to 1. Meaning, you can use it as a shortcut. If I want to find probability of one event, I can subtract the other from the total 1. Okay, only when if they are mutually exclusive and collectively exhaustive. Okay, then we got to understand what are simple events, compound events, right? Finally, we just recalled algebra of probabilities. What is it? P of two events, either A or B, which is denoted by union, which can be written as probability of A plus probability of B minus probability of A intersection B. Similarly, if A and B are mutually exclusive, then P of A and B will become 0. Then P of A union B will be directly what? P of A plus P of B. So next point, if A and B are independent. If A and B are independent, then P of A intersection B can be written as P of A into P of B. There is similar formula for three terms. P of A union B union C is P of A plus P of B. Yes, I'll write here. Plus P of C. This formula is very similar to the formula we use in set theory for intersection of 2 or 3 sets, right? P of B intersection C. Yes, I'll write here. Plus P of minus, right? Yeah, P of C intersection A. Entire thing plus P of A intersection B intersection C. Okay.